Hi, I'm Larry Puckett, the DCC Guy. Today I want to give you a look at the DCC Concepts Alpha Mimic ground signal system. You know, these are quick and easy to install on your model railroad because they use quick connects, and therefore you don't need to do any soldering at all in most applications. So let's take a look at this system. But first, hit that little red subscribe button, and when the little bell comes up, click on it and click all. Thanks now. So then, first off, what is a ground signal? Well, in the US, they're actually referred to more commonly as dwarf signals. And in the UK, they're called ground signals. Now, here in the US, we also refer to them as ground signals, but you'll hear dwarf signals more commonly referred to. And they're basically a small version of the typical large mast-mounted signals that you see along railroads. And basically, they were designed to be used in areas where you might have a lot of congestion, such as in yards, and areas where you've got basically fairly slow speed operations. So you might see them again in yards, and also at sidings where trains would be coming in off of a siding into the main. You might see them at an industrial spur somewhere where a train would be coming again into the main. So you're basically using them to protect the main and prevent trains from entering the main without permission and without having a switch thrown for them. Now, on your particular prototype railroad, if you do follow a prototype, this operation might be different. So you might want to take a look at exactly how your prototype operates their signals like this, and become familiar to a certain degree with their signaling practices so that you can implement these, following that prototype practice. Or you can freelance it and follow rule number one. It's your railroad. You can do what you want and do it the way you want. And so what I've done is I've set up a demo here on the workbench showing you how they work with one of their Cobalt IP digital switch machines. And then I'll swap the components out and we'll take a look at how that works with a tortoise switch machine, because you can do it both ways. Okay, so what I've done is on this piece of styrofoam here, I've set up a quick demonstration to give you an idea of how these work. So we have a turnout right here. So this would be the main line right through here. And this could be a passing track. It could be a siding. It could be a spur coming in off of an industry, whatever. And as you can see right now, if a train were coming in this way, they would get a red light. And, the basic operating rule on the railroad is you don't pass a red light unless you have orders to the contrary. And that would be specific orders received from the dispatcher or someone telling you that you can go past a red light. So any train coming then in off of one of these sidings is going to be stopped at this point, and the mainline trains could go right on through. Then, once we throw the turnout, and I'll show you in a minute how I'm doing that, you'll notice that the main line now has the red light and the switch has been thrown, and we have a green light here on the siding side. So that indicates and tells the engineer of that locomotive that he has permission to go ahead, enter the main line, and he's got a green light showing that. Now, as I said a minute ago, your prototype may operate differently. It's very common on some of these to have yellow lights as well, and to use yellow instead of green. And you just have to go back and look at your prototype operations in order to understand exactly how they implemented these. Or you can just go with this red-green stoplight type of an approach and work that way to simplify the whole operation for your operating crews. Now let's take a quick look over here as to how I was throwing that switch. So this right here is one of the DCC Concepts Cobalt IP digital switch machines that I've shown you in previous videos. And I'll put a link to the 2 videos that I use these in above me here, and you can take a look at those. Now, one of the neat things about this is this whole system was designed for use with the cobalt switch machines. So that gives it, you know, a much easier type of installation, a much cleaner installation. Now, one thing that I didn't show you in the previous video that is very neat is this is a little standard momentary push button. And by attaching both contacts of this push button to the left and right PB or push button contacts here on the switch machine, by simply pushing that little momentary push button, it activates the switch machine. So this is a really neat option on these IP digital switch machines. So, you know, on the NCE Switch 8 accessory decoders that I've been using for a lot of my turnout controls, I had to buy an additional button board in order to just use push buttons with the Switch 8 accessory decoder. On this, it comes built in. So that's another option that really makes it slick. So you can just throw that and it reverses your switch machine. Now, that also reverses the polarity of power that's being fed to those 2 ground signals. And you can see right here, this is the wire that goes from the switch machine to the circuit board that controls those little LEDs. So you have the 2 DCC power input wires here, and those feed into these red and black wires that go to the circuit board. And right here, the little green wire connects to the frog polarity contact, and that changes the polarity on the board. Now right here, and I'll show you I'll give you a closer look at this in a minute, but right here is the little circuit board that they designed to do all of this. So you connect your DCC wire here, and that's the DCC power that it takes out from the switch machine. And then there's 2 connectors here for your little LEDs. So all of this, you just pop the connection in here and make the connection right here with these little plug and socket connections. So there's no soldering involved. So it's a very straightforward system, easy to put together. I mean, it's just a simple matter of pushing the wires into these little spring-loaded contacts, as I've shown you in the previous video on how these work, hooking everything up to the board, and installing your LEDs here on your layout. And you've got it ready to run. I've shown you how this works with an IP digital switch machine using DCC power. But as I said earlier, you can use these with the Cobalt analog and Omega switch machines, and you can also use these with tortoise switch machines and similar types that run off of DC power. So let me go ahead and bring on the tortoise switch machine and the various components that go with it, and we'll take a look at how that works. Okay, let's take a look at how this tortoise switch machine operation actually works. In the previous video that I did on powering your tortoise switch machines using the DC power and a switch like this one, you can take these 2 wires that go to the DCC concept circuit board and connect them, red and black, to the red and black wires, or to the 2 wires that feed the correct polarity to your tortoise switch machine. So that each time you reverse the direction of the turnout using the tortoise, it also reverses the polarity that goes to this device, which controls your LEDs on the layout. Now, one thing they point out, never connect power through both of these to the board at the same time. You'll blow it, okay? You can either have DC power fed into it or DCC power into it, but not both at the same time. And also, these are polarized. They will only fit in one way. So if you try to shove it in and it doesn't go, don't keep pushing. Turn it over and push it in the right way. That's how it works with DC, and I showed you a minute ago how it works with DCC power. I've zoomed in here on the workbench where I've got the various components for the Alpha Mimic ground signal system or dwarf signal system laid out for you. Before I get started on describing each one and what they do, I want to point out that this is not a paid promotional video for DCC Concepts. They have provided these materials to me to do a review. Let's go ahead then and take a look at each one of the various components. As I mentioned earlier, the difference between a ground signal or a dwarf signal like this one here and the standard mast signal is that they allow the railroad to install these in very, very congested areas such as yards where it might be more difficult to install a bunch of these mast type signals, because these are down at ground level. They're, the clearances are much better for installing these than something like this, and it's just a lot cheaper for them as well. So you can look into what your prototype used and where they used them, that kind of thing. So these then are a Westinghouse design pre-World War II, and I'm sure they lasted well into the modern era. There might still be some out there in operation today. And this is what you get from DCC Concepts. Now they come in a 4-pack, or as you can see here, they come in a 12-pack. And I've taken a lot out here to do this video. This is just bare plastic. So one thing that I'm doing with mine before I install them in the layout is I go ahead and I do some dry brushing with gray primer paint in order to make some of the details pop here on the ground signal or dwarf signal itself, and also on the mounting base. So let's take a close look then at the actual dwarf signal itself. So you can see that it's got quite a nice detail, and as I said earlier, it's based on a Westinghouse pre-World War II prototype, which I'm sure continued in use much into the modern era, and these might be still available in use somewhere in the United States still. The great thing about these is you can change the mounting base here so that it either goes acrosswise or it can go 4.5 for very close installations, very tight installations. I'm using this configuration for installing these between 2 tracks, and it makes it a lot easier. Now typically these might have been cast concrete originally. In many installations today they use fabricated metal bases for their dwarf signals. So that's something you want to look into for your own railroad. You could cut these off and make your own bases. Do what you need in order to make it look right for your model railroad. Okay. Basically, then this wire here is about 6 or 7 inches long, which is, depending on where you place the circuit board, the controlling board, is going to be plenty long enough for a lot of installations. However, just in case you run into situations where the length of run is going to be longer, the folks at DCC Concepts also sell these extensions. And these come in sixes, groups of 6. So you can buy a 6-pack that are 150 millimeters long, 300 millimeters, 750, and then 1 meter long, about 3 feet. So you can really extend these out. In the package with the signals, they include these little circuit boards, and there are 3 of these. They allow you to connect 2 LEDs on one side of the circuit board and then connect it to an extender. Let me see if I can find that one. So here they provide you a 2-wire that goes into a controller board like this. And then you can plug this in here and attach 2 of the ground signals or dwarf signals right here. And there are situations where you might want to have 2 lighting up at the same time with the same color. For example, with a double crossover, you might want to have a red showing on the opposite sides in order to prevent trains from trying to go through a closed double crossover turnout. So those are just, and you could do the same thing here. As I remember, these are rated at about 100 milliamps, so you don't want to overload these with too many of these daisy-chained together. So that comes with the basic ground signal itself, and they provide 3 of these inside the package of 12 of the ground signals themselves. What other things come here? Well, let's take a look at the board itself, because that's pretty neat. So this is the controller board. This wire here goes to a DC power source, such as the power supply that is controlling your tortoise switch machine. So you have one set of wires, one connector that is with 3 wires for the DCC version, and you have 2 wires that go here for the DC version. And one thing they point out, never connect these up and power them at the same time. You can only have either the DC power or the DCC power being fed into the circuit at a time. Do not try to do both at the time, or you might blow this sucker up. Okay, so those both are included with each one of these little boards. One of the things I like about the design is these are designed so that they can fit right in here in this slot that is cast into the case of the digital switch machine. So you can just put a couple of pieces of double-sided tape or some foam tape right here and attach it directly to the switch machine that it's going to be working with. Or it's got 4 little mounting holes right here, and they include screws in the package with the device. So you get packages of screws that come with them in order to be able to mount these to the underside of the layout, for example. And these come in singles or in 3-packs. Now another neat thing that they have on here is once you've got your power hooked up, either the DC or DCC power, and your LEDs hooked up to it, and everything working, then right here there is a little trim pot. So this is an adjustment potentiometer that you can use with a little screwdriver, and you turn it in order to adjust the brightness of the LEDs. So that is one thing that I thought was pretty nifty. They did provide that right here on the board for you. So if they're too bright, you can knock that down a bit. Another thing, they mention in the instructions, or they show in the instructions, that these operate off of 12 to 18 volts DC. Now I ask because in a lot of cases, like when I'm using my Switch 8s, they only put out about 9 volts DC to control the tortoise switch machines. So I wanted to know, okay, is that going to work? And so I checked with the folks at DCC Concept, and they told me that they had tested these down to about 7 volts DC, and the LED brightness is perfectly fine at that point. You probably won't be able to adjust it down any lower at that point, but that's about as low as you're going to go, is 7 volts DC. So if you want to find out more about these, I recommend you go to the DCC Concepts website. That's dccconcepts.com, and look up alpha mimic ground signals. You might need to do some searching for this control board. These are the ground signal interface DCD-GSC.1 and GSC.3. And that is this ground signal interface, and that allows you to set it up to work with the tortoise switch machines or the Cobalt digital or Omega or analog type switch machines. Okay, let me point out that the US version of the Dwarf Signal is produced in HO scale, whereas the 3 UK versions are all 00 scale. And one of those UK versions looks almost identical to the US Westinghouse version, except it'll be just a little bit larger. So be aware of that. As far as availability goes, right now your best bet is to go to either the dccconcepts.com website and order the products from their online store, or you can order them from one of their UK dealers, such as Rails of Sheffield, Hatton's, the Model Center, and various others. And I'm pretty sure that on the DCC Concepts website, they have a list of their various dealers where you can place orders. And there are Australian dealers as well for you guys down under there. Now, as far as North American dealers, Heartland Hobby Supply is the distributor here in the U.S., but typically I think they run a little behind on getting inventory in from the U.K. They usually wait until the hobby shops start asking them for the products before they'll start bringing them in. So you probably won't be able to get them here in the U.S. right away. There is a hobby shop, though, in Canada that has a U.S. shipping address as well, and they are going to be getting these things in inventory. They do have a certain limited amount of various DCC Concepts products already on their website, but most of this stuff that I've shown you today, they just don't have yet. They haven't been able to get it in over here at this point, but they will be getting that in. And for all of these suppliers, I will place a link to their websites in the description to this video. So if you're interested in trying to get a hold of these, please go ahead and check the description. Your best bet, if you want these right away, is to go to the DCC Concepts website and order it from them or from one of the UK dealers. It usually takes about a week to get a shipment from the UK, and you know, that's about the same as it takes to get my dealer to get products from Walthers and ship them to me. And the shipping costs are about the same as far as shipping from the UK to me here in North Carolina as it does to have products shipped from the hobby shop that I buy from down in South Carolina. So I hope I've given you a clear overview of the components that are available for installing these ground dwarf signals on your model railroad. And on Monday or Tuesday, I'm not sure which day I'll be able to get it put together, but hopefully it'll go together fairly quickly and I'll be able to do it on Monday. But at any rate, what I'm going to have is a part 2 to this video. And in part 2, I'm going to install these ground signals, these dwarf signals, on the Piedmont Southern to control a switch that I'm installing in Amherst, Virginia. And for that, I'll be using one of the Cobalt IP digital switch machines. And that'll give you an idea of just how quick and easy it is to install these. You know, the hardest part and the most time-consuming part in all of this really is installing the switch machine itself. And once you've got that done, it's just a simple matter of plugging the sucker in and you're ready to go. So come on back on Monday or Tuesday for part 2 of the video where we'll do an actual on-the-layout installation. In the meantime, have a good weekend, and we'll see you here on Monday or Tuesday with part 2 of this video. Bye now.